So good morning to all. So we had studied last term fundamental units, derived units, their importance, importance of measurement, and so on. So I had given you some work on the last term. So let us have a check what you have done. Speed, meter per second, I had already done. Velocity, meter per second. Acceleration, meter per second square. Area, meter square. Volume, meter cube. Density, kg per meter cube. Force, kg meter per second square. Work, kg meter square per second square. Power, kg meter square per second cube. Pressure, kg per meter per second square. Frequency per second. Energy, kg meter square per second square. So this was the solution for the work which I had given. So we begin with our today's class. Further going into the chapter. So I move to the next slide. Now in this slide I have a table with prefix, symbol and its value. Now what are prefixes? These are put before any unit and it gives a value to the unit. Suppose if I say milli. So milli if I put in front of meter, so that will mean 10 to the power minus 3 meters. So these prefixes are here. This is to be learnt by you people because it may be asked in the examination to change from one to the other. So you should know this. So these are pico, nano, micro, milli, centi, deci, deca, hecto, kilo, myria, mega, ziga, tera. And the values are given and the symbols are given. It may be that the prefixes are not written in complete, only the symbols are given. So you have to recognize them by symbols also. So this table is important. You have to learn this with the values. It is necessary for you to convert from one form to another. So we go to the next slide. Now in this slide, we are going to study about the standard measurements. So I told you that the standard things for measurement were taken as length, mass and time. That day I mentioned. According to which the system of units have been made. That these are the three fundamental quantities. So we begin with the first one, that is length. So what is the standard unit of length? From where is it evolved? How do we know that this is only 1 meter? So these are the definitions given here. So according to it, a meter was originally defined in 1889 as the distance between two marks drawn on a platinum iridium. Platinum iridium is a alloy which is 90% platinum and 10% iridium. So these two marks which are drawn on this rod and kept at 0 degrees Celsius in the International Bureau of Weights and Measures at Sevres near Paris. So this was taken earlier. Then later on it was defined as 1650763.73 times of the wavelength of a specified orange-red spectral line in the emission spectrum of krypton 86. So emission of krypton 86 was done and then orange-red spectral line was seen and the wavelength of that and 1650763.73 times of that wavelength was taken as 1 meter. Then later on in 1983, whatever was defined at that time is still continuing. In 1983, the meter was redefined in terms of speed of light. And how was it? That 1 meter is the distance traveled by the light in 1 upon 299792458 of a second in air or vacuum. That means distance traveled by light in these many seconds will be 1 meter. Now what are these many seconds? You know the speed of light is 3 into 10 to the power 8 meters per second. So whatever is given here in denominator, when we when we round it off, will always become 3 into 10 to the power 8. That is the speed of light. So the distance traveled by light when light travels in these many seconds will be 1 meter. So you have understood this? So we move to the next slide with some bigger units of meter, smaller units, centimeter, millimeter. I have given you the prefixes. You can put the prefixes and you can find the values. Micrometer is also known as micron. Micro is also taken as micron. Nanometer, centimeter, millimeter, you can make it as you want. So we go to the next slide. Now here in this, I have taken astronomical unit. So we defined one astronomical unit as equal to 1.496 into 10 to the power 11 meters. You have to learn this. It may be used in changing from one unit to the other. Then we have light year. Now, some people confuse when it is written year here, so they take it as unit of time. But this is unit of distance. And how is it? Light year is the distance traveled by light in 1 year, in vacuum or air. So light year is light when the distance traveled by light in vacuum in 1 year. So it will be taken as 1 light year is equal to speed of light into time in 1 year. So 3 into 10 to the power 8 meter per second into 365 days into 24 hours into 60 into 60 to change it in seconds. So it comes to 9.46 into 10 to the power 15 meters, and that is equal to 9.46 into 10 to the power 12 kilometers. Then we have another unit of it as angstroms. Angstroms will be 10 to the power minus 10th part of a meter. So 1 angstrom will be taken as 10 to the power minus 10 meter. And there is one more unit, Fermi, which is taken as 10 to the power minus 15 meters. So these are some units with consideration to length, which we have studied, and we also have to learn it because it may be asked to convert from one unit to other. So now we come to unit of mass, and you know that SI unit of mass is kilogram. So what is 1 kilogram? So according to the definition in 1889, 1 kilogram was defined as mass of a cylindrical piece of platinum iridium alloy kept at International Bureau of Weights and Measures at Sèvres near Paris. So it is the weight of that cylindrical piece of platinum iridium which is kept over there. Later on, it was 20th May and which is continuing till now in 20th May 2019. It is that defines mass in terms of fundamental values called Planck's constant. And the value of a Planck's constant is 6.62607015 into 10 to the power minus 34 kg meter square per second. The Kibble balance, which makes use of Planck's constant, measures the mass of an object using a precisely measured electromagnetic force. So this was defined as 1 kilogram. So you have to learn the definition. Maybe ask that what is 1 kilogram or define 1 kilogram. Now sub units, gram, milligram, you can put the prefixes and find out. You must have heard about quintal, which is equal to 100 kgs, and metric ton, which is equal to 1000 kgs or 10 quintal. So we go to the next slide with unit of time. Now, I had to speak about time in the last slide only, but I missed out time over there. So unit of time is seconds. SI unit of time is second, and it is defined as 1/86400th part of a mean solar day. So what is one solar day? It is the time taken by Earth to complete one rotation on its axis. So time is defined like this. Time is also defined as 1 second is the time interval of 91926317770 vibrations of radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium-133 atom. So when cesium-133 atom vibrates, and these many vibrations of that cesium atom will be taken as 1 second. So these were the definitions of length, mass, and time. And you know the subunits and other units of time: minute, hour, day, month, year, leap year, decade, century, millennium, and so on. There is one more, lunar month, which you don't know. Here, 1 month is the time of one lunar cycle, which is nearly 29.5 days. The period of 12 lunar months is 354.37 days. Thus, 1 year of these lunar calendars is short nearly by 10 days of our calendar. So this is the time. Now, there are some rules to how to write the units. There are some rules given. This slide is on that only. So the first rule is that if the symbol is not named after a scientist, it will always be written in small letters. And second, if it is on name of any scientist, the first letter of the name will be taken and it will be written in capital letters. Then, if it is not the name of a scientist and we have a unit, it will never be written in capital letters. Like kilogram, the K of the kilogram will be small, not capital. Then, if there is a compound unit, that means mixed with two units, then in that case, there will be a space and we have to write the compound unit formed by the multiplication of two or more units and is written by putting a dot, cross, or leaving a space between the two symbols. For example, the unit of torque will be written as Newton dot meter or Newton into meter or Newton space meter. Okay, Newton is the name of the scientist, so written in capital letters, and meter is normal, so it is written in small letters. Now, if there is any negative power like meter per second, so negative power is used for compound units, which is formed by dividing one unit by other. So in that case, unit of velocity, suppose we take unit of velocity, it will be meter per second. Unit of power, joule per second, expressed as joule. Joule is the name of a scientist, and per second. Then next one is the unit in its short form is never written in plural. Like we have 10 meter. Now we will not write 10 meters. We will write 10 meter. Next is to avoid powers of 10 in the magnitude of a quantity, prefix can be used. That is why the prefixes are given. You won't take it in the powers of 10. The unit will not be written in powers of 10. So you will use the prefixes as and when required. And the last one is when prefix is used with a symbol of unit, the prefix and symbol combined become the new symbol of the unit. Like if I take kg meter cube. So kilometer cube. So kilometer, kilometer will have 10 to the power 3 meters and kilometer cube will be 10 to the power 3 meters whole cube. So it becomes 10 to the power 9 meter cube. So it does not mean 10 to the power 3 meter cube. It means 10 to the power 9 meter cube. I hope you understand. Okay, so we go with some of the numericals in further slides. So now I have a question. The wavelength of light of a particle of a particular color is 5800 angstroms. Express it in A, nanometer, B, meter. Now, I have the solution here. 1 angstrom is 10 to the power minus 10 meter. We have mentioned it earlier also. And 1 nanometer is 10 to the power minus 9 meters. Now, if I have to compare angstrom with nanometers, if I take 10 angstrom, if I multiply 1 angstrom by 10, that will be 10 to the power minus 10 meters into 10. Now minus 10 power minus 10 and plus 1 becomes minus 9. So 10 angstrom become 10 to the power minus 9 meters, which is equal to 1 nanometer. Now, if I have to write 1 angstrom, it will be 1 nanometer upon 10. So 5800 angstroms is equal to 5800 upon 10 nanometer. That becomes 580 nanometer. And the next part, we have to convert to meter. 1 angstrom is equal to 10 to the power minus 10 meter. So 5800 angstroms is equal to 5800 into 10 to the power minus 10 meter. That is 5.8 into 10 to the power 3. In physics, we always write only one digit before the decimal. And if there is no digit, we write 0. So we write only one digit before the decimal, and that is why I have written 5.8 into 10 to the power 3 into 10 to the power minus 10. And when we calculate, it becomes 5.8 into 10 to the power minus 10 meters. We go to the next numerical. Okay, so we have another question here. The size of a bacteria is 1 micron. Find the number of bacteria in 1 meter length. So micrometer or micron I mentioned is 10 to the power minus 6 meters. So 1 micron is equal to 10 to the power minus 6 meters. So 1 meter will be 1 upon 10 to the power minus 6 microns. That becomes 10 to the power 6 microns. So in 1 meter, we will have 10 to the power 6 bacteria. So we go to the next numerical. So here we have the distance of a star from Earth is 8.33 light minutes. What do you mean by this statement? And express the distance in meter. Light years we had studied, distance traveled by light in 1 year. So light minutes will be distance traveled by light in 1 minute. So we will calculate speed of light into time in 1 minute. So 3 into 10 to the power 8 meter per second into 60 seconds, which comes to 180 into 10 to the power 8 meters. So we'll multiply this by 8.33 light minutes. So it will become 8.33 into 1.8 into 10 to the power 10 I have written, because we should have only one digit before the decimal. So this becomes 14.994 into 10 to the power 10 meters. And that is 1.4994 into 10 to the power 11 meters. That is equal to 1.5 into 10 to the power 11 meters. So this is few of the numericals. I'll give you some homework also right now. Please try to do the numericals and questions on your own. Look for the answers. Whatever I have given you, the answers will be from there only. Try to do it on your own. So when we meet in the next class, I'll discuss with the answers. Okay, so thank you. We end up with the class now. Okay, take care. Bye-bye.